for a natural number as well as an infinite series. We'll extend that for exponential, logarithmic, as well as the partial fraction. So these are the topics. How far it's possible, I think we will cover. Okay. Whenever we do, it's not a regular academic part, and since it is a combination of students from class 8, 9, as well as 10, somewhere class 8 students need the basic formula, okay, or class 9 students require some formulas which already class 10 students may be knowing. Sometimes I think for all the three classes, the topic or the problem what we are going to discuss may be a new. Okay. But the concept, the basic part, okay, once if you are able to get, I think you can solve any number of problems. So mathematics is nothing but normally solving 100 problems. If I solve 100, if I give 101, new one, I think not that you are supposed to get a solution, but you see that I think you are able to try the steps. Okay, that's why I think in the morning all the dignitaries said, don't bother about the result. Okay, if you are able to understand there's a problem from this, yeah, my approach may be like this, and few steps if you are able to arrive, I think then itself I think you will have an something, yeah, confident, yeah, it's possible for us. Okay. Shall we start? Okay. So the first this session, as I said, we'll go with the concept of progressions. Whatever I'm going to discuss, just I will brief the term. Uh, what I mean by info my handwriting will be clear to the last bench. Okay. What I mean by a sequence, then I'll come for series. Then we will discuss something about progressions like arithmetic progression. The 10th standard students they may be knowing. Then we will go for geometric progression, harmonic progression, and you have one more set of progression. We call it as AGP, arithmetic geometric progression. Uh, Finally, I think we will have a combination of problems. We will do few problems which is based on your Olympiad level also. Usually, what we will think is Olympiad means the problem will be very lengthy. Generally, the problem will be 2-3 steps. Only thing, something it should spark on your mind. So if you start like this, yeah, I will have the answer. Most of the problem with the Olympiad, if I say, will be based on these AP as well as GP combinations. Okay. Anyway, I'll go one by one. Okay. Maybe for first, maybe half an hour, we'll go with the basic way. Then we'll go. We'll accelerate. Okay. Then you will have an interest. Okay. I'll start with the sequence. Okay. I'll say simply a sequence is nothing but a list of elements, just you place it. Okay, suppose if I say numbers 1 to 25, not necessarily I think you should say in increasing order or in a decreasing order. I'll say 1, then I'll say number 2, then I'll say the number 4. Can I write like this? So if I take the number 1, then I'll take 2, then I will write 4, then I'll go with the number 8. I think this is one pattern. Okay. Ultimately, what you are seeing is nothing but a list of numbers which are placed. Okay. Suppose if I take the numbers starting from 2, then I go with the number 3. I think obviously you will be able to say what is this? 2, 3, 5, all prime numbers, isn't it? So the sequence means it is nothing but a set of or list of numbers, just you place it. That is nothing but a sequence. We will define what do you mean by sequence in general in mathematics. How we will define means sequence will be denoted by the symbol generally S suffix n. S suffix n stands for the sequence. It is defined from the set of positive integers to a real number. Okay, carefully listen. It's a next level of thing. How we are defining a sequence means sequence should be defined from where? only from the positive integers to the final answer. What we are going to get is nothing but a real number. Real number means it varies from minus infinity to plus infinity. So it is nothing but a rule. It is nothing but a rule which is defined from one particular set to another particular set. So what I can say is this is nothing but a set I. I stands for positive integers, and I have here is nothing but R. So what I have is a mapping. I can call an association. That is, whatever element you take, I am going to define a rule such that I will have an element here. The rule what you are going to define, we call that is nothing but a sequence. Remember what I said is you are going to define. So ultimately you define a rule such that this condition should be satisfied. Suppose if I define a rule, Sn is equal to take 2m plus 1, and we used to write like this, and I will write here n pronunciation. N varies from 1 to infinity, because I said I stands for what? Positive integers. So we won't start with the number 0, so we'll start with the number 1, and I have defined a rule is nothing but 2m plus 1. Now what I will do is I will put n equal to 1, n equal to 2, and so on. So here I have the numbers like this 1, 2, 3, 4, and it goes on up to infinity. For each number, you find an association. Association in the sense you find an answer with respect to this particular rule. Suppose if I put n equal to 1, what I will get is 2 plus 1. The answer will be 3. So I have here the number from minus infinity to plus infinity. So this number 1 is associated to what number? 3. So in functions topic, we call this as the image. We call this as the image. So image of this number 1 under this particular rule, what I am getting is 3. So I will write my first term. First term S1 is nothing but S1 means you are substituting n equal to 1, and correspondingly you are getting the answer equal to 3. Now just increase the number. N equal to 2. What I will get? 4 plus 1. The next number will be 5. So here 2 will be associated to number 5. So if I proceed like this, so if I put n equal to 3, the next number will be 7. If I put n equal to 4, the next number will be 9. So I am getting a set of elements. What I said is nothing but initially you just place the elements as it is, we call it as a sequence. Now I have defined a rule, a sequence. With respect to this particular sequence, I am getting a pattern of numbers which follows some particular rule. Am I clear? So think of this particular example, one example. I will define one more example. Suppose if I take Sn equal to, shall we take 1 by 2 power n. Let us start with n varies from 1 to n. Okay. Or as a special case, I will start with n equal to 0. Even though I said it is set of positive integers, carefully listen, we have a flexibility. Suppose if I start with n equal to 0 to infinity, it's an exponent part. So we start with n equal to 0. If I put n equal to 0, anything power 0? 1. So what I will get, my first term will be 1. Now we start with n equal to 1, 2, 3, and so on. So what I will get is 1 by 2 power 1. That is 1 by 2. Next number 1 by 2 square. That is 4. Next number 1 by 8. It goes on. So remember this example. We will discuss maybe after some time the same example. Okay. So what we are having here is, as your number, see these two examples. As your terms increases, try to understand what I am saying. As the term increases, is the value of the term also increases? Isn't it? So as n goes more and more, the terms of the sequence value also, I think it increases. But in the other way, if you see here, as the value of n increases, the value of the terms of the sequence is it decreases, isn't it? So what I am going to say is, when the terms of the values of the terms of the sequence are going increasing, I can use the word as diverge. There is no a point where it approach. But when you see here, as the value increases, the values of the term as n increases, the term values, can you see where it approaches to? It approaches to what number? It approaches to 0. Here 1 by 4, here 1 by 8. If I put n equal to 100, 1 by 2 power 100, 1 by maximum is what? Minimum. Alright, 1 by maximum value will be minimum. So as the value increases here, this is large, large and large. 1 by larger number will be a smaller number. So as n approaches to infinity, this 1 by 2 power n value approaches to what? 0, the value. So finally, all the values are approaching to a particular point. What is that point? 0. So in mathematics, we call that as convergent. We call it as a convergent. So convergent point means it approaches to a particular point. But in this case, I think it's not converging, it diverges. It diverges because numbers also increases, n also increases, the term value also increases. Okay. Now you just see, I'll take one special sequence. Can anyone say what will be the terms of the sequence? Any one of you? My sequence is nothing but -1 the whole power n plus 1 where n varies from 1 to infinity. Number 1, -1, 1. So you won't have more number of terms. You will have only two possible answers. Either the answer will be 1 or the answer will be -1. So can I write like this? The answer will be 1 if, can I say n is odd? If I take odd number, put n equal to 1, n equal to 3, n equal to 5, this power becomes even. -1 the whole power even is nothing but 1. And if I go with n as even number, my answer will be -1. So ultimately what I will get is, I will get 1, -1, 1, -1, and it goes on. Can I have a guesswork? What we call such type of sequence? I said guesswork. Here I said it diverge. Here I said it converge. Here I think it is not diverging. Diverging means it goes on. Converging means whatever may be the terms, it should approach to a particular point. I think both fails here. It's neither approaching to a particular point nor diverging. Can I have a guesswork? 1, then -1, then 1, -1. Yeah, so especially, that's all, nothing else. We call the sequence as an oscillating sequence. It oscillates between either it will have -1 or it will have +1. Only these two are the possibility. So for your progressions, the basic part what you need is a sequence. How the sequence will be defined? Sequence is nothing but a rule you define, and such that you will have a set of numbers, and we call these as your terms. We call it as a terms. Generally we mark it as T1, we mark it as T2, T3. T stands for the number of terms. Tn is nothing but your terms. Okay. So starting part is nothing but sequence. Now series, because we are going to solve more problems on series. Series is nothing but if you give the arithmetic operation plus or minus symbol between the terms of the sequence, we call that as a series. Okay, so you have the numbers is nothing but 1, 2, 3, 4, and it goes on. It is the terms of the sequence. If I say 1 plus 2 plus 3 plus 4 plus etc., This I call it as a series. That means series is nothing but from the sequence where I can use the word insert either a plus operation or minus operation. So again plus and minus. Okay. Afterwards I think we'll go with the multiplication also. So series is nothing but summation of all the values, that we call it as a series. Okay. Now we'll come for the term progression. When I say progression, your term should follow certain pattern throughout the set of series. Okay. So as we discussed the first number, suppose if I take the number 3, 5, 7, 9, 11. Obviously, this second number you are getting by thinking of the first. Third number you can get by thinking of the second number, with some constant criteria is applied here. Okay. So 10 standard students, obviously you can say these numbers follows a pattern of increasing each number by 2, so that I will get the second number. Second number you increase by 2, I will get the third number, and the system goes on. Okay, it may be a finite or it may be infinite. Okay, once if you have such type of pattern, increasing pattern or rather a decreasing pattern, we say the terms are in arithmetic progression. We say the terms are in arithmetic progression. So I repeat, I will give few examples. So arithmetic progression means, suppose if I start 1, 5, 9, 13 and so on. This will be the first number, I call it as T1, and the second number I am getting by adding the number 4. Third number I will get by adding 4 to the second number. This number I will get by adding the number 4 to this number. That means that 4 is somewhat a fixed constant. 4 is nothing but somewhat fixed constant. So that fixed constant we call as common difference. We call it as what? Common difference, and we will mark it as D. We will mark it as D. And always the first term is represented by the notation A. A stands for the first term, and D is nothing but a common difference. So I will generalize that term. Generalize. So my first term will be A. The second term will be A plus D. Third term will be A plus 2D. Identify the 10th term. So when I say 10th term, you just observe, is it a third term? No max is required. Since it is a third term, what number I have written? 2. So when I write the fourth term, I will write number 3. Isn't it? So when you write the 10th term, can I write that as 1 less of 10? 19. Isn't it? You extend the logic. When I say nth term, n is some number defined. When I say nth term, it should be 1 less of n. 1 less of n is nothing but n minus 1. So that is the way I think you might have done in 10th standard. The nth term of arithmetic progression means a plus n minus 1 into d. So the generalization, this part will serve you solving most of the problem when the terms are required. For that you need two basic things. One, you should know your first term, and one is your common difference. So three things are required: A, B and M. So once if I have this, whatever term required, I can calculate. So the first rule for your arithmetic progression is the terms of the sequence. And once again saying, the terms of the sequence which follow this particular rule are said to be in arithmetic progression, where this we call as the first term, and this D we call it as a common difference. We call it as a common difference. So I will write the common difference as, so we write like this: second term minus first term. Answer 4. Third term minus second term, third term minus second term, that is also equal to 4. Then fourth term minus third term, that is also equal to 4. In the beginning I said just you add the number. The same thing I said in a different way. If I proceed second minus first, third minus second, fourth minus third, all you should have a same number, constant. Then only I can say that set of elements or the set of numbers are in what? Arithmetic progression. Okay, that's the first rule. So remember, nth term is what? Generalization. We will write the nth term as Tn, which is a plus m minus 1 into t. So that is your nth term. Now, suppose the terms are given in arithmetic progression, how you are supposed to find the sum? Okay, and as I said, your arithmetic progression may be a finite AB, sometimes it may be infinite number of AB. So we will restrict ourselves only for a finite number of terms for time being. So what I need is now Sn sum to n terms of AB. Generalization of arithmetic progression is a plus b plus a plus 2d. What about the last term? A plus n minus 1 into d. Okay. Just observe, maybe class 10 students may be knowing this. Okay. Others. Now, how to get the summation? Remember, A is unknown. A is unknown in the sense it's not a number. T is also a general number, isn't it? Let us take this as number 1. What I'm going to do is, you just observe. Suppose if I want to find the sum of this, 1 plus 2 plus 3 plus 4. It's an easy one. So you will say, sir, I'll add, so I'll get the answer equal to 10. But when you have more numbers, isn't it? How to get the answer? And once again, is these terms are in AP? Starting with the first term? What is the common difference? 1. Yeah, I need some answer from you people. So, okay, common difference is 1, A is 1. Answer is 10. But what I will do is, the same yes, you write in the reverse order. From here you write, okay, but below this. So you write 4 here, then you write 3, then 2, then 1. Remember, the sum remains the same. Now what you do is, you add 1 and 2. If I add 1 and 2, what I will get is 2s. Add in the sense, vertically you add the numbers. That is, this and this you add. I'll get 5. This and this? 5. This 2? This also? How many times? Because how many terms are there? 4 terms. So can I write that as 4 into 5? So ultimately the answer is 20. 2s is 20. S value is equal to 10. Okay. Remember, this is a simple one. I apply the logic here to get your formulae. Okay. So now, what I will do is the same Sn start from this term. This is my last term. Can I say here one more term? It should be a plus m minus 2 into t. This is last term. This is last but second, and it goes on. This will be my first term. Reverse it. Start from the last term. A plus m minus 1 into t. This and this finally I should add. Plus, the next term is a plus m minus 2 into t. This and this I should add. And it goes on. And obviously the last part is nothing but a. The same number. That's why I have given this example. I think hope you got. Now when I add the term vertically, what you are going to get the same answer. How many times? 10 times. Because how many terms are there in the AP? 10 terms, isn't it? So what I will get is when you add a plus n minus 1 into t. This and this if I add, what I will get is 2a plus a, 2a plus n minus 1 into t. So when I add, I will write 2 times Sn will be 2a plus n minus 1 into t. How many times? 10 times. For this, okay, How I got 4 means I have 4 terms, that's why 4 into the summation. Here n times into the summation. So what I need is Sn. So I can write Sn as 2, you bring it down. So it should be n by 2 into 2a plus n minus 1 into d. So this is the second one what you need in your AP. Sum to n terms of the arithmetic progression is n by 2 into 2a plus n minus 1 into d. So you should know the first, you should know the common difference and how many terms are involved. Once if you know, if I substitute all, I will have the solution. Just we will modify this like this. Can I write this n by 2 into this 2a, you write a plus a, the remaining part you write as it is. Put a parenthesis. A plus n minus 1 into d. But according to me, a plus n minus 1 into d is which term? Last term, tn, isn't it? So you call it as a nth term. Sometimes you use the symbol as L. L stands for the last term. So can I write this as n by 2 into a plus L? So the same formula we can write as this. Why we need this means when the first term and the last term is given and how many terms are given, I think it's not required about your common difference. Alright, I'll say the first term is 3, last term is something like 41, let us assume. So I don't know about the common difference. I'll say the terms are in AP and I have 20 terms. You have number of terms is there, first term is there, last term is there. Shall we use this formula? N by 2 into a plus a. So identify what is given in your hypothesis or the proposition, based on that you apply. So the basic part of the progression will start from arithmetic progression, where you need these two. One is to identify the term, the other one is to find the sum. Either one is to find what? Sum to n terms. Am I clear? 10th standard, I won't have a doubt. What about 9th and 8th? Okay. So two things, try to understand. When you say the terms are in AP, so provided it should follow a pattern with an increasing order or decreasing order with a fixed constant, we said a common difference, and generalization of nth term, and how to find sum to n terms. Now I will go for one more concept in arithmetic progression. We call that as arithmetic mean, because we are going to solve some 5-6 problems based on some inequalities. Okay, arithmetic mean, I will say. Even in statistics, you have the term. Okay, average. So, how will you say average of two numbers? What you will do? You will add divided by 2, isn't it? But we have some criteria here. So I will say 3 numbers which are in arithmetic progression. Carefully observe. I have taken 3 numbers which are in arithmetic progression. When I say these are in arithmetic progression, according to my rule, second term minus first term is same as third term minus second term. So shall I write this as b minus a equal to c minus b? Now what I will do is, this minus b you bring this side, this minus a to that side. So what I will get? 2b equal to a plus c. So what I will have is b equal to what? A plus c divided by 2. This b we call as the arithmetic mean of what? A and c. So I have the abbreviation, then universal standard notation. AM stand for arithmetic mean of these two numbers. Arithmetic mean of these two numbers. Our problems will be based on this. So to find the arithmetic mean of two numbers, just you add and divide by 2. If you want to find the arithmetic mean of 3 numbers, you just add divided by 3. The logic is this. Okay. So hope you got what I mean by this. Now the question is, just listen. Afterwards you can note it down. Your question is now, I give 2 numbers In between the numbers, you are supposed to insert some arithmetic means. Okay, what I am saying is just observe. Between two numbers, you are supposed to insert some arithmetic means. I'll start like this. One is one number. Let us take and starting with a simple example. You are asked to insert four arithmetic means, not four numbers. You are asked to find four arithmetic means between the numbers 1 and 11. Between the numbers 1 and 11. When I say arithmetic mean, the criteria is what? The numbers are in arithmetic progression. So what I will do is, I will write 1, A1, A2, A3, A4, comma 11 are in where? Arithmetic progression. Remember, arithmetic means the terms are in AP. The terms are in AP. Now, is it the first term? Second term? Third? Fourth? Fifth? Sixth? So, my sixth term is 11. Isn't it? T6 is 11. Can I use this formula? So, T6 can be written as A plus 6 minus 1. 5D equal to 11. What is my first term? First term is 1. If I substitute 1 here, 1 plus 5D is 11. 5D is 10. The value. You got that common difference? Once if you know the common difference, can I have the numbers? This number will be 3, 5, 7, 9, 11. Now, just see, you didn't calculate one arithmetic mean. You have done 4. Now, suppose if I take this part, can I say this 3, am I right, is the arithmetic mean of these two? Yes. 5 plus 1, 6 by 2, 3. Let me just check it for any 3 numbers continuously, which should be in AP, which should be in AP. So once again, I repeat, this part we need for our problems now. Once if I define GP, I'll combine, we'll have the problem. So to insert arithmetic means, I need this particular logic. Now, listen, suppose you are not going to find, just observe, you are not going to find the arithmetic means. But what I need is their sum. What I need is their sum. So to get the sum of 4 arithmetic means, I'll take this the first term A and take this as your last term B. And since I said 4 arithmetic means are required, I will generalize the formula sum of 4 arithmetic means between 1 and 11 is, my formula is n by 2 into a plus b. No need to calculate this. If I know the first term and the last term, without calculating your whatever arithmetic mean, I have a formula. Now, shall I apply? How many arithmetic means? 4. So can I write 4 by 2? What is my A? 1. What is my B? 11. 12. 12 by 2. 6. 6 into 4. 24. So just sum it up. 9753 you add. What you are getting? Whether you have calculated arithmetic means, not required. So just to find not only 4, any number of arithmetic means are required. To find their sum without calculating your AMs, you have a rule n by 2 into first term plus last term. That A and B is our notation. First term plus last term into number of arithmetic means divided by what? 2 will give the sum of the arithmetic means between the numbers, provided the numbers are in arithmetic progression. So I summarize the last time. Nth term, sum to n terms, and the arithmetic mean of 2 numbers is given by a plus b by 2 or a plus c by 2, that you call it as b. Okay. Is it okay? Now shall we move for the second progression? Okay. Geometric progression. Okay. When you think of geometric progression, you have the basic concept of geometric progression is the second sequence example what I wrote. If you see the example 1, then 1 by 2, 1 by 4, 1 by 8, and it goes on up to infinity. So remember, arithmetic progression is with respect to addition subtraction concept. When you think of geometric progression, the series terms are geometrically increased. Geometrically increased. Geometrically means I think the growth, I can say it may be exponentially positive plus or it may be exponentially down. That's why we call it as a geometric series. We call it as a geometric series. The rule is starting with a number, then we will generalize exactly like AP. I'll take this is the first term. As usual, A. Multiply this by half. Previously, I said you add in AP. Now I'm saying multiply by half. This answer you multiply by half. This answer you multiply by half. That means each and every next term you are getting by multiplying the previous term by half. Alright? Or the other way, can I divide this by this? Can I write T2 by T1? Or can I divide T3 by T2, which is same as T4 by T3? Everything is nothing but a constant. The first way I said you just multiply. The other way I am saying divide. Like AP I said you either increase plus or what we said common, difference, subtract. Here you just multiply like this or divide this way. You are supposed to get a constant term. Then we will say the terms of the given sequence are in geometric progression. They are in geometric progression, and this we denote by the symbol R, and we call it as a common ratio. How we used to say common difference, here we will call that as what? Common ratio, which is denoted by the symbol R. Now I will generalize. Okay. So first term is A. Can I multiply this by R? What I will get? AR. Next term? AR squared. Next term? AR cubed. The same way. Is it my fourth term? What is my power? 3. So when I write the 10th term, my power should be 9. So AR power 9. Can I generalize? When I have nth term, it should be 1 less. So it should be AR power n minus 1. AR power n minus 1. Just see for your comparison. It is for AP. Now I am giving for GP. What is my nth term of geometric progression? AR power n minus 1. A is given to you. R is nothing but a common ratio. Common ratio. N is nothing but a number of terms. Once if we have, we will have the nth term, 5th term, 10th term, 100th term. Any term if you want, I think you will get. It depends upon the value of R. And remember, your R may be greater than 1, R may be less than 1. In common difference, I think we didn't say anything about. I said it may be increasing or decreasing. But here we have some restriction in the sense criteria for your R. So R is greater than 1 criteria, R is less than 1 is one criteria. Now, shall we go for this sum like AP? Now, Sn stands for AR plus AR squared plus AR cubed and so on up to AR power n minus 1. The same process we will do. In your AP, what we have done to find the sum? Reverse. But here what I will do is, I will just multiply this by R. And remember, definitely R cannot be equal to 0. Because you are using the term T2 by T1, T3 by T2. So definitely R cannot be 0. R may be positive, R may be negative, any number. So you just multiply by R. But after multiplying by R, how I am going to write the term you see? When I multiply by R, what is my first answer? AR. That AR you write here. Next term will be AR into R, AR square. Am I right? It goes on, isn't it? So when you multiply this, you are getting this one. So when you multiply this, what I will get? AR power n. N minus 1 plus 1. Loss of exponent. So what I will get is AR power n. This I multiplied by R, so I am getting here. Here the term will be AR power n minus 2. If you multiply, what I will get is AR power n minus 1. Alright, so just you multiply by R, but only thing is, I have written the numbers terms one below the other, this order. Just you subtract this and this. What I get is Sn minus Rsn. If you subtract, see the term? These terms get cancelled. AR get cancelled, AR square get cancelled, AR power n minus 2 get cancelled, AR power n minus 1 also get cancelled. The terms left out are AR power n and here A and you are subtracting. So can I write A minus AR power n? Can I take A common? Then what I get? 1 minus R power n. Here can I take Sn common? What I get? 1 minus R. What we need ultimately? Sn. So can I write your Sn as A into 1 minus R power n by 1 minus R? So this is the formula for sum to n terms of GP. Sum to n terms of GP. Important thing is, I'll say my R value should be less than 1. R value should be less than 1. Because what we are having here? 1 minus R. Sir, suppose if R is positive, what happens? No issues. When you substitute R as positive, that is greater than 1, even if you substitute, numerator also you will get sometime negative number, denominator also negative number, ultimately the answer will be positive. So, you have two possibilities when you write your sum to n terms. One is A into R power n minus 1 by R minus 1. For R greater than 1, R will be more than 1. More than 1 minus 1. Positive. Am I right? That's why I will think of this formula. If R is less than 1, 1 minus R will be positive. R is less than 1, 1 minus R will be positive. So I will get once again this particular formula. So whatever you want, I think you can use once if you are asked to find your sum to n terms of GP. Only thing, if you remember exactly this particular part, you will get. Now, just listen. Now we will take the value of R is less than 1. It is for finite term. Suppose if you have infinite number of terms, that is the speciality of GP. You will have infinite number of terms, you can find the sum. So if R is less than 1, can anyone say what will happen to R power n as n is very large? The value cannot be equal to 0. The value approaches to 0. Because the same example you can take. Can I take my common ratio as 1 by 2? So as the number of terms is more, suppose if I take 100 terms, it will be 1 by 2 the whole power 100. 1 by 2 the whole power 100 is a smaller quantity. Am I right? Still increase your n as 1000. 1 by 2 the whole power 1000 will be still smaller quantity. So as the n value increases, your R power n value approaches to what? 0. It will not be equal to 0, it approaches to 0. So this formula, this value approximately equal to what? 0. So what I will get is S infinity. S infinity stands for sum to infinite number of terms. Now this value is 0. Which is left out? 1 into A by 1 minus R. So my answer will be S infinity will be A divided by 1 minus R. So I have three things: nth term and sum to n terms of the geometric series, and S infinity is given by the formula A divided by 1 minus R. Now, this is the formula. Now, what we'll do is, how we define your AM, arithmetic mean, like the same way we will define your geometric mean. We'll define the term called geometric mean. So take once again three numbers A, B, C, which are in geometric progression. If three numbers are in GP means the rule will be what? Second term by first term equal to third term by second term. Multiply, cross multiply, what are you get? B squared equal to AC. Are you able to get? Second term by first term equal to third term by second term. This one, cross multiply. B squared equal to AC. What I get? B is equal to what? Square root of AC. Actually, we call it as a mean proportional in ratio and proportion. So, in geometric progression, this we call it as geometric mean of what? A and C. So, I said AM. Now, I have GM is nothing but what? Square root of AC. That is nothing but. See, remember everything we are writing for A, B, C. Afterwards, we will just go with the number. Yeah.
So, can we consider the negative value?
Positive integers. Negative numbers you can take, provided both A and C should be negative. Then only square root becomes positive. Because within square root, you are not supposed to get any negative number. Such number exists, that number is not a real number. That number is not a real number. So, you can take both the numbers as negative, applicable. Both the numbers as positive, applicable. One number positive, one number negative is not applicable. So, you cannot find square root of minus 4. It doesn't belong to what? R. But you have a number system, even in your schedule it is that complex numbers, one topic is given. So, as I said, this number is not a real number, but that number is a complex number. So, when we discuss AB, GP, all these things are restricted to real number system. So, that's why what you ask is good. Both should be plus or both should be minus. Then only square root of the number is given. Alright. Now, the most important for our problem, so far we didn't do any problem, we have discussed the basic part. For the problem purpose, I am going to find the relation between your AM and GM. I am going to find a relation between AM and GM. So this is my inequality. Arithmetic mean is always greater than or equal to geometric mean. So arithmetic mean, the terms are in AB. In geometric mean, the terms are in GP. So once if we have both, I can have this particular relation. Okay. Just to observe how we are going to justify this. This is the rule. Okay. Arithmetic mean is always greater than or equal to geometric mean. We'll take the same thing. Or let us take your arithmetic mean as A, capital A. That is A plus B by 2. I have taken two positive numbers. A and B belongs to R plus. So just now I said arithmetic mean means add these two divided by 2. Geometric means you represent as capital G, which is nothing but what? Square root of A. So for two numbers, the A arithmetic mean is A plus B by 2 and geometric mean is nothing but what? Root of AB. Now we'll just do this. Listen, afterwards if you want you can write. It's a property, you just remember it now. I'll start with A minus G. A is arithmetic mean, G is geometric mean. I'm starting with what? A minus G. A is what? A plus B by 2. G is what? Root AB. I should prove this answer should be greater than or equal to 0. Inequalities. I should prove this answer. Difference of these two should be either 0 or greater than 0. That only if I prove, then I have this answer. What we will do is, First you take LCM. If I take LCM, what I will get? A plus B minus 2 root AB divided by 2. This 1 by 2 you write first outside. These 2, can I write like this? Alright? Root A the whole square. A, root B the whole square. B, and this term as it is. Is it of the form? Is it of the form? A minus B the whole square. That means it is root A minus root B the whole square. Root A minus root B the whole square is nothing but this. Anything the whole square is a positive, isn't it? And I said AB belongs to R plus. So A is a positive number, B is a positive number. Suppose A and B are equal, I get this answer equal to 0. In that case, I will get A minus G is 0 means A equal to G. Equality. A and B are different. Then definitely the difference will be some number, maybe positive or negative, but what we are having? Whole square. Definitely this will be what? Positive into 1 by 2. Is it positive? So greater than 0 definitely. If A and B are different, equality holds good, then A and B are equal. So ultimately what I proved? A minus G is greater than or equal to 0. That means A is greater than or equal to G. So arithmetic mean is always greater than or equal to geometric mean. So that is my first part. The relation which connects your AM as well as GM. Arithmetic mean and geometric mean. Is it clear? Now we are going to solve the problems, at least 2-3 problems based on this. Maybe in between I'll ask questions. See that I have some answer. Okay. Am I clear up to this? Okay. The results are here. The final result, what we discussed is this particular problem. Okay. We'll start with the problem. Just note down problem. Problem based on AM and GM. Approach, how you are going to apply the rule to get your answer. That only. So the problem is A, B, C, D are, note it down. These are some problems in Olympiads where the 3 or 4 steps will have a solution using this. Actually, nothing will be mentioned in the problem like A, B, G, P. Nothing will be there. Only thing you have to identify this concept is applicable to get the solution. Okay. So the question A, B, C, D are positive real. I can use R plus positive real satisfying the condition satisfying the condition A plus C into B plus D equal to AC plus BD. So this is the condition given to you. Find the smallest possible value of this A by B plus B by C plus C by D plus D by E. You are asked to find the smallest possible value of this. Okay. This is, as I said, these are all the next level, higher level problem. Okay, Olympiad level problem. Anywhere in the problem, anything is specified about your AP, GP, AM, GM, nothing. Simple given ABCD are positive numbers, and one particular rule is nothing but this condition is given. And the question is, yeah, this one, A. This one. This is D by A. It's in cyclic term. A, B, B, C, C, D, D, D. And most of the problems will be symmetrical. Symmetrical means it will be a continuation or cyclic term. Okay. And the question is you are asked to find the maximum, smallest possible value of this. Smallest possible value you are asked to find. How we are going to apply your AM and GM concept, you just see. Grouping the terms. So what I am going to do is, I will take this and this term. I will take A by B is one number and the second number is nothing but C by D. Okay. First number is A by B, second number is C by D. These two you take. Okay. Just listen, I will give a minute time, you can write it down afterwards. Because once if you understand, you can do it. Now what you do is, apply the AM-GM inequality. What is AM-GM inequality? In general, A plus B by 2 is greater than or equal to what? Root AB. A is first number, B is second number. Now, this is my first number, this is my second number. You apply that rule for these two. So what I will get is, A by B plus C by D by 2 is greater than or equal to root of A by B into C by D. Am I right? Now, this 2 will bring, and you don't take anything, you keep as it is. A by B plus C by D is greater than or equal to root of AC by BD. Can I take this as 1? So this and this I have taken and I applied your inequality, AMG. Now, 2 more numbers are left out, isn't it? These two we will take. So for B by C and D by A, apply the same logic. So what I will get? B by C plus D by A by 2 is greater than or equal to root of B by C into D by A. Now once again this 2 will come. What I will get is B by C plus D by A is greater than or equal to 2 times BD by AC. Am I right? So just you observe, nothing is mentioned about your problem about AM, GM. So, but I have done the AM, GM inequality for that also, not the first and second. First and third, second and fourth. Now what you do is, what I need, smallest value for this. So if I sum, okay, just sum it up, 1 and 2. That means this and this you are adding. When you add, I will get this one. That is the answer what you need, isn't it? So when I add 1 and 2, what I will get is A by B. I am writing in order. A by B, B by C, then C by D, then D by A. Just you add this and this. But remember, it is not equality. It is greater than or equal to. So you have to write greater than or equal to. When I add this and this, 2 is common. So I can add, is it root of AC by BD plus root of BD by AC. Okay, listen, this part is over because I need the answer for this, the smallest value. See here, greater than or equal to. Now I will write that is equal to, don't write here greater than or equal to, because this term is equal to, take LCM. Can I write this as root AC by root BD plus root BD by root AC? Now take LCM in the sense cross multiply. If I cross multiply, what I will get? AC here, BD by root of ABCD. So what I will get is here AC plus BD by root of ABCD. Still remember, we didn't use the hypothesis. What is the hypothesis? A plus C into B plus D is given as what? AC plus BD. We didn't use. Now I use AC plus BD can be written as A plus C into B plus D. Carefully listen, don't write, because somewhere something we have to do. 2 into, here I will write A plus C into B plus D by root of ABC. Equality by this condition. Now the major part. What I will do is, Once again, you apply that logic. AM is greater than or equal to GM. For A and C, A plus C, can I write A plus C is greater than or equal to twice root AC? Am I right? Similarly, B plus D will be greater than or equal to twice root of BD. Third time I am applying your AMGM. So I will write this is greater than or equal to this number 2 as it is. Denominator also as it is. No change. Now, why I put greater than or equal to? Because this will be greater than or equal to what? Twice root AC. A and C are the numbers. AM is greater than or equal to twice GM. So I will write this as twice root AC. What about this? Twice root BD. Am I right? Numerator is what now? What is numerator? Root of ABCD. That root of ABCD and this root of ABCD get cancel. What I will get? 2, 2, 2. Answer 8. So my answer is nothing but it's not equal to 8 because I have used your equality. So A by B plus B by C plus C by D plus D by A is greater than or equal to 8. Shri, what is the question? Smallest. When I say the value is greater than or equal to 8 means it takes values from 8 onwards. What is the least value? So the conclusion should be answer for the least value, the smallest value of that equal to 8. Am I clear? You just see how we approach the problem. Okay, that only takes. Otherwise, once if you get that idea, use the hypothesis, I think you will come to the solution. Any doubt? Yeah. Yeah, louder. ABCD are real numbers. Pardon? When is that? For what value of ABCD, the expression will be equal. Yeah, equality holds good when A and C are equal, B and D are equal. Yeah, you can check. I will give the value for that. A and C are equal. You take equal to 1. Actually, if you solve, and if you take your B equal to D equal to, it is irrational number, 2 plus 2. Okay. If you take this value, equality holds good for this. Otherwise, it will be even inequality. Because in your hypothesis, we didn't say the numbers are equal. We didn't say the numbers are equal. We said the numbers belongs to R. So what you asked, the equality, exactly you will get the answer equal to A. You can check, provided this condition. So the process I just tell you, in the given hypothesis, you put C is equal to A and your D equal to B. Then what you will get is, here you will get 2A, here you will get 2B, 2A into 2B, what I will get is 4AB. Here also I have to replace C by A, B by B. What I will get is A square plus B square. Remember, it is a quadratic, but it is not quadratic in one variable. So what I have to do is, I should write like this. Just observe. Okay, for you, just I am solving, not completely. A squared minus 4AB plus B squared is 0. Just you make it as quadratic means divide throughout by B squared. I will get this answer. If I divide by B squared throughout, I will get A squared by B squared minus 4AB by B squared plus B squared by B squared 1. 10 standard students may be knowing this. Is it a quadratic? But it is not quadratic in one variable. It is a quadratic in A by B. The variable is nothing but A by B. You apply the quadratic formula, I think you will get the answer as 2 plus or minus root 3. You will get the answer as 2 plus or minus root 3. So if you take 1 as 2 plus root 3, the rationalizing factor will be 2 minus root 3. So that's why in 2 roots you will get. And finally the equality holds good if A and C are equal to 1. So all the numbers we cannot take as a irrational. So 2 numbers we have taken as a positive integers and one set of numbers in terms of irrational inequality codes. So that is all. Okay. Yeah, any doubt the approaching way? Okay. Only thing, as I said, when you do number of problems, then only you will get an idea how to get that particular part. And most of the problem, the question will be what is the largest value, what is the smallest value. So it is not exactly prove that equal to. Okay. So shall we go for one more to get the solution? Next one. Just remember the way solutions we are solving, and if you have any alternative way of solving the problem, easy method, apply that. Okay. Next one. If A, B, C, D are four numbers, here more calculation will be involved. Okay. Anyway, I'll simplify it. If A, B, C, D are four numbers, such that A greater than or equal to B, greater than or equal to C, greater than or equal to D, greater than or equal to D, and A plus B plus C plus D value is 1. Prove that A plus 2B plus 3C plus 4D into A power A into B power B into C power C into D power D is greater than 1. A power A and all the numbers are positive, even I can say greater than 0 you can take. A value is greater than B, greater than C, greater than D, and all the numbers are positive, no negative number. And you should prove A plus 2B plus 3C plus 4D into this part is greater than 1. It's a pure algebraic problem that we won't think of AM or GM. Okay. Uh, Progression numbers, series is given or something like that. We'll start with, in order to prove that answer, what we are going to do. Okay. I'll start with this part. This part we will modify into a smaller expression. Shall we write? And whenever you have inequality is involved, you justify by means of some numbers, then I think you will satisfy. Otherwise, I think if I take all A, B, C, D like that, I think sometimes I think you will have a doubt. Now, what I will write is this value will be greater than or equal to, just observe, that is your A power A into B power B into C power C into D power D will be greater than or equal to, this side it is the product, but here I have written as a sum, this particular part. Alright, so you just see each and every term and criteria you remember. A value will be greater than B value. That means for all A, B, C, D, which is a larger value. Which is a larger value? A will be a larger value. Now what I have written is, this A power A will definitely greater than or equal to A square. Because if I take A is equal to 1, answer is 2. That is true. If I take A as 2, it is A square. A square can be written as A into A. So numbers, whatever number you want, you just give the number for A and check this particular condition. Suppose if I give A is equal to 2, 2 power 2, 4. 2 into 2, 4. Am I right? Suppose if I take 3, 3 power 3, 3 into 3 into 3, 27. But here I will write 3 into 3, 9. So 27 will be definitely greater than 9. That's why I said justify whenever you have your inequality. So what I have written is a power a will be greater than or equal to a into a. Similarly, this is b into b. This is c into c. This is d into d. Then you should ask that then why in between plus? How is greater than? Since a is a greater for all the values, b is greater than c and d, c is greater than d, definitely your a square plus b square plus c square plus d square, this value, all the values, this value will be definitely less than this particular part. Or in the other way, this value will be definitely more than this particular part. Once again, justify with the numbers. So, what I am going to do is, instead of a power a, b power b, c power c, d power d, we will now replace by the term a square plus b square plus c square plus d square. So, that particular part, a plus 2b plus 3c plus 4d into this becomes a square plus b square plus c square plus d square. What I should prove? I have to prove this value is greater than 1. Anyone? Can I have a hint? You should prove the value. I'm sorry. Take this as less than 1. To prove the value is less than 1. So, not greater than 1. The value should be less than 1. Now, not greater than 1, less than 1 to prove. Now, just see what I am going to do this particular part. This 1 can be replaced by the criteria a plus b plus c plus d. Remember, I am not solving the problem. In order to prove this particular part, you prove this particular part. I said, that is to prove, in order to prove this, you write a plus 2b plus 3c plus 4d into a square plus b square plus c square plus d square should be less than this 1 can I write as a plus b plus c plus d the whole cube. Can I ask why whole cube? Anyway, it is a plus b plus c plus d. A plus b plus c plus d is what? 1. I can write even 1 square, 1 cube, but I will write the term as exactly 1 cube. That is 1 the whole power 3. The purpose is, I will take this particular part. I am not going to write the steps now. Okay, we will use the algebraic identity. Take this particular part and expand. After expansion, if you see the answer, okay, I start with a plus b plus c plus d the whole cube. Using your algebraic identity, a plus b the whole cube can be written as a cube plus 3a squared b plus 3ab squared plus b cube. I have to use this formula, but that is for 2. Now I am having how many numbers? 4 numbers. Now I won't write that in detail stuff. You just see. I will take this as the first number, this is the second number. Apply this logic. Okay, that's the way you are supposed to get. Maybe afterwards you can just check. This is the first number, this is the second number. Apply this part. Once again, you will get a plus b the whole cube, and here what I will get? C plus d the whole cube. So that also you have to multiply, expand. Then if you simplify, I will get some symmetrical term. I will get some symmetrical term. So the term will be, I will take a square, I will write the term and check. You just see what I am writing here. And the way what I am writing is just observe. After your expansion, usual expansion using the formula a squared into this plus b squared into just check the numbers what I am writing. Okay. Here I start with 3. I start here 3a, 4b, and here c, and here we will have 2. The numbers 1, 2, 3, 4. What I am having? A square. So for a square, I have written. So you write 1a, 2b, 3c, 4d. Then you have written b square. So it should be 1b. Sorry, just check it. Yeah. It should be here 1b. Then I have 2c. Then I have 3d. Then I have 4e. after expansion. Then when I write the term c square, I will have only 1c, then I will have 2d, then 3a, then 4b, and when I write d square, it should be 1d, then here 4a plus 3b plus, 1, here 2a, then here 3b, and here 4c. You just see the terms 1, 2, 3, 4, same way 1, 2, 3, 4, only the expression. So nothing difficult. What you do is apply this formula first, then once again expand this and simplify the term. And if you simplify the term, I'll get this particular total part. Okay. Now remember what I have to prove is this total value is less than this. I started with a plus b plus c plus d there, whole cube. Now what I will do is this is I will write greater than, I'll justify once again this into, you just see how what I have written for finally. That is the term a plus 2b plus 3c plus 4d. I can see all these things. So that means this should have a common term. Then only I can take the total as a common. What I will get? A square plus b square plus c square plus d square. So now the justification from here to here is a and a are equal, and 2b is also equal. 3c here I am writing as 3c equal 4d with 4d, that is also equal. But if you see here, this 4a will be definitely greater than a. 4a will be definitely greater than a. And what I am having here? B. B will be greater than 2b, isn't it? And here 2c, here the number will be 3c. But remember, B value will be greater than C value. B value will be greater than C value. C value will be more than D value. So that means when I have here 2C and here 3C, since the summation B is greater than C, that when I add this, and this, definitely this sum will be greater than this particular part. This total, each total parenthesis will be greater than a plus 2b plus 3c plus 4d. So ultimately what I proved is a square plus b square plus c square plus d square into this is less than a plus b plus c plus d the whole cube. But a plus b plus c plus d value is what? 1. So that means this into this value will be less than 1. Less than 1. No AM, GM, it's a pure number theory, algebraic number theory problem based on your inequality and a simple identity a plus b the whole cube formula. And before that, what you need is this particular step, rather this step. How I have written a power a into b power b into c power c into d power d is greater than or equal to a square plus b square plus c square plus d square. That part. It's not immediately you can get because more inequalities are there, and how to modify the terms, that once if you get, then you will have the simplification. Just if you want to just make a note, okay. One or two simple problems we'll do so that I think you will have some interest. Okay, otherwise all the problems will go like this. Yeah.
So in the third step, we have substituted a value which is smaller than the original.
This one.
So how
This one.
we have substituted a value which has smaller value than the original.
Yeah. So what I have done is instead of having the powers that is in terms of exponents, a power a, b power b, c power c, d power a. So I just modified that value as greater than or equal to this particular part. So this value is definitely greater than or is equal to this. But ultimately what I have to do is this should be less than 1. Only thing I am saying about this particular part, this value is definitely greater than this. This value is definitely greater than this means the final solution will not affect. Are you able to get? This value is definitely more than this value means This is a larger value. Then for the larger value, the answer is 1. For smaller value, definitely it will be less than 1. The total product is less than 1, not this value is less than 1. So we need to prove this particular part is less than 1. Because when I say A power A, B power B, how many times you will write A power A? We don't know. A goes up to how many number of times? So that's why we made it as number 2. Okay. Since I have taken the number as 2, I modified here the number as 3. That's why I said you may ask that why you have taken 3. The exact reason is if I take the value as only 1, then A power A, B power B, C power C, D power D will be exactly equal to A, B, C, D. Because A is 1 means 1 power 1, 1 power 1 like that. A, B, C different values you should give. At the same time, it should satisfy the criteria of this particular part. Alright, so this value will be definitely greater than this value if the minimum has 2. Since I have taken for the minimum power here, that's why I have taken the next number as 3. If I take the number 3, I should think of 4. This itself is a lengthy calculation. If I go with the power 4, once again it will be lengthy. That's why the minimum number you take and justify the particular answer. Once again I repeat for your question, we will modify this particular part. You are not asked to do this and this. Just we replace this value is definitely greater than this particular value. When this value is more compared to this and the product is less than 1 means this product also less than 1. Answer will not be same, but it will be definitely less than 1. What I need is the answer should be less than 1. Not the answer I should get as 2 by 3 for that, and here it may be some number less than that. But ultimately the answer should be less than 1. What I need. Any doubt? As I said, deviated from your AM. Once again, it will come for AM. Okay. Afterwards, you just expand and see this particular one. And inequality problems, that is the number theory problems. Inequality problems where you should use your inequality, whether it should be greater than or equal to, or less than or equal to. That's why I said whenever you have a doubt, give numbers and justify it. Justify, yeah, with the numbers it is true, so I can put the symbol. Then you go. This one of your problem in your Olympiad level. Simple one. I'll give you a minute time. You give me the answer. Okay. If ABCD belongs to real plus, I need the answer only from you. If ABCD belongs to R plus, comma, A plus B plus C plus D is equal to 2. Capital M equal to A plus B into C plus D. I have 4 options. Okay. Which value will be true? 0 less than or equal to M less than 1, 1 less than or equal to M less than 2. So M satisfies which criteria? I'll give the hint. Use your AM and GM inequality. Only one step. Use AM and GM inequality. And which option is correct? We'll do some 2, 3 like this. Use the inequality and say which option is correct. It's a purely MCQ level. And give me the justification. I said use your AM and GM criteria and also use the condition given. The hypothesis is A plus B plus C plus D is 2. And use 2. Select the answer from the given option. M is positive. Yeah. Put 1. Yeah. Okay. I'll wait for few more minutes, few more seconds. Then I will discuss. Anyone else? Option 4. You have used your AM greater than or equal to GM. Okay. Yes. Anyone else? This is the rule. This is the rule I am saying. This rule you use. A plus b by 2 is greater than or equal to root of AB. I have two sets of numbers. That's one more second step hint. Take A and B, apply GM. A and GM. Then take C and D, apply the same AM and GM constant. I have given the second step hint. Take A and B, apply your AM greater than or equal to GM. Then take C and D, apply your AM is greater than or equal to GM. Then use the hypothesis. It's a 1 minute problem. That's why I have given the hint. Use AM, GM criteria as well. Anyone? Any other option? Yeah, I feel free to say. Do you have anything? Yes, answer.
Sure.
Yeah.
Option 1. Option 1.
Someone?
Option 1.
Option 1. Anyone? Yeah, only 4 options are there maximum. Yeah. Yeah. Option 1. Can I have a look?
Just write some numbers.
Okay. Yeah, you can think of, yeah, that's fine because sometime in your exams, I think the inequality cases, I think you can substitute the numbers and you can justify. But you cannot take for every number. How you will take all numbers and justify? And remember, only sometime it will fail, not always. Okay. Because for the first 10 numbers, it may be true. 11th number, it fails. Then you cannot conclude. Yeah, first option he said, 1 is the 4th option. Yeah. Huh? Option number 1. Option number 1. Option 1 is nothing but the correct answer. That's all. A simple one. So apply the logic here. A plus b is greater than or equal to twice root AB. Now for this also you apply the same logic. How will you write? C plus d is greater than or equal to twice root of CD. What I need is A plus b into C plus d. That is your M. So just you multiply A plus b, am I right? Into C plus d. Can I write this? Sorry, you just add A plus b plus C plus d is greater than or equal to twice of root AB plus root CD. Alright? Now A plus b plus C plus d is nothing but how much? 2. Actually, this value, isn't it? Now this is 2 of root AB plus root CD. Anyone goes to what afterwards?
Root AB plus root CD is 1.
Okay. Root AB into no. So we applied your AM concept, GM concept for 2 numbers, A plus B as well as C plus D. But ultimately what you are getting is when you add the numbers, you will get A plus B plus C plus D, isn't it? But this value is nothing but 2. It is given, isn't it? But this side, now just see, like this. Alright. A plus B is one number, C plus D is one number. The arithmetic mean of this and this is greater than or equal to twice root of A plus B into C plus D. Am I right? A plus B plus C plus D value is what? 2. This is 2. This 2 will come here. This is square root of A plus B into C plus D is nothing but what? M. So 1 greater than or equal to root M. If I square, 1 is greater than or equal to M. That is M is less than or equal to 1. That means 0 less than or equal to M less than or equal to 1. If I take, just observe, if I take the terms separately, carefully observe why we didn't get that answer means this answer what I will get is nothing but 2. But this side you are not getting the term what I need. A plus B into C plus D I need. You won't get that particular part when you simplify it. Am I right? So what I have taken is this as one number, this as one number, apply your AM and GM criteria, then use this hypothesis here, and this is exactly your M. Your option is nothing but wrong. So M value lies between 0 and 1. So that is the exact way of proving the solution. Yeah, anything? How you got fourth option? Any method? Yeah. So then the arithmetic mean for this. That only we have done finally. Instead of doing separately, calculation. Yeah. One more MCQ. Okay. For 3 positive real numbers, this is one of your Olympiad problem. Okay. For 3 positive real numbers A, B, C, which are in AP, for 3 positive real numbers A, B, C, which are in AP, such that A, B, C is 4. The question is, what is minimum value of P? What is the minimum value of P? So the options are some numbers 2 power 1 by 3, 2 power 2 by 3, root 2, and 2 root 2. So I'll say use the basic concept of arithmetic progression. Use the basic concept of arithmetic progression. Yeah. Option B, 2 power 2 by 3.
Option B.
Second option or third option?
Second option.
Second option. Okay, is it second option? Yeah. Anyone? Second option. Second. Maybe trial and error method. Trial and error method means maybe substituting the values such that I think criteria. Yeah. Can you have the method? How you approached? AP. APGP. The condition is ABC having arithmetic progression only is given. Okay. Yeah. So 2B is the possibility. Then B continuity 2 possibility minus 1 yeah. 2 root 2 yeah. AMGM. AMGM is not required. I said use the basic part of arithmetic progression, you will have the answer. Basic part of AP, you will have the answer. That's it. ABC are not in GP. You have used B squared equal to AC. ABC are in arithmetic progression, not in geometric progression. It's not a one-line solution or something. Okay. Anyone? Okay. Just you observe. Since this is in arithmetic progression, shall I modify like this? Okay. Answer. Anyway, once if it is MCQ, if you select by chance the correct answer, okay, it's okay. But the process B minus A equal to C minus D equal to D. See the condition given. ABC is 4. What I will do is, I will change these two also in terms of B. Then only finally I will get the value for B. Am I right? From here, can I write B as A plus D? Or can I write here A? This A you bring it to that side. B minus D is equal to A. And from here, you write your C is equal to, I write B plus D. Everything you are writing in terms of D, and remember this D is a fixed constant. D won't vary. It's a common ratio. Now you just see, can I write A as B minus D, B as it is, and this is B plus D, the total equal to what? 4. Now just you see once again, the question is not the value of B. You are asked to find the minimum value. It may be less than that also, isn't it? So equality will not come once again. Now this and this you multiply. What I will get? B into B squared minus D squared is equal to 4. Now what I am going to write, you just observe. 4 equal to B into B squared minus D squared. Am I right? This B I will write as it is. Now this particular part I am going to replace as less than B squared. Anyone? Once again I repeat, the question is not to what is the value of B, what is the minimum value of B. So what I have done is, B squared minus D squared is a number. Is it a number? Now what I have written is, this B squared minus D squared value will be definitely equal to B squared if the value of D should be 0. But D cannot be 0, common difference. So now, this value I just remove. So your B squared minus D squared value will be definitely less than what number? B squared. Definitely less than B squared. Suppose if you take this as 15 and this is 10. So 15 minus 10, my answer will be 5, isn't it? So 5 is strictly less than 15 squared. Yes or no? 5 is definitely less than 15 squared. So what I have written is only in terms of B. Now is it nothing but B cube? So B cube is equal to what? 4. Can I have the value of B? B value will be 4 power 1 by 3. 4 power 1 by 3 is nothing but 2 power 2 by 3. Option is nothing but 2. Option may be correct, but the process of getting the answer will be this the particular way. The remaining part of GP problems and your binomial theorem we'll discuss in the afternoon part. Okay. Anyway, if you have a time, just give a thing. If you have a doubt, I think you can ask.
Hello. So I would like to thank sir for such an amazing class. I really appreciate the way he taught us, and his lecture was quite useful to enhance our knowledge in the topic of progressions. Uh, Thank you, sir.
Thank you, Arya. I hope this session would be excellent. I was misfortunate to not be here. Thank you, sir. Thank you for guiding our children, and I hope the next session will also be so much fruitful once again. So now I would like to welcome our principal, sir, Mr. Vijay Kumar Shukla. So, sir is having master's degree from Banaras Hindu University. He has joined ACS GAGA in 2008. And from 2008 to 2013, he was in ACS GAGA. Then he was transferred to ACS 4 Ravagata as postgraduate teacher in mathematics. Now, 2021, he has become vice principal in ACS 2 Ravagata, and now he is here as a principal. 2023 onwards, May 2023 onwards. So, I would like to welcome you, sir, for guiding our children.
The student sitting in the last row, are you able to see the board properly? The things